So I just wanted to quickly demo something I've been playing with recently. It's a simple volume slider, something you'd see in pretty much every video game. I just wanted to talk about how you map the value of the slider onto the actual volume that you set in your audio library or audio API. So obviously the naive approach is just that the slider goes from 0 to 1, in the background in the range of 0 to 1, and you just apply that directly to the music volume, right? So I'm using raylib in this example project here, and I'm setting the music volume to log vol, which is a temp var that's just set to new volume, and new volume just comes from this IMGUI float slider, right? So 0 to 1, drag it, get a float, and set the volume to exactly that. So let's demo that quickly. So you may notice that in the high range, the amount that the perceivable volume changes when you drag the slider is very, very little at all, right? The difference between 0.5 or 50% and 100% of the volume slider is a very small difference in volume. So I'll show that again quickly. Right, you can barely tell the difference between it when I drag the slider in the top range between the volume. Conversely, in the lower end of the range, you'll notice that the volume slider feels extremely coarse. You really don't feel like you have any control over the volume, and it just jumps large amounts. So let's demo that quickly as well. Right, there's really not anything quieter than like 0.1 because it just jumps to barely audible from dead silent very quickly. So how do we solve this problem? There are a million different equations that you could choose instead of this that are better than this, logarithmic equations. The internet has all sorts of articles and examples of such equations. I've played around with it a bit and empirically decided that, at least with my audio setup, that I like this equation. So what is this equation, right? We have an exponential portion. This is a ternary statement, right? So the second portion of the ternary statement, the main meat of this function is this exponential function here, which is just 5x minus 5, right? Where x is the volume slider value in the range of 0 to 1. And then there's also this thing where at 0.296, which is the intersection between these two lines, we just revert to a linear function, which is 0.1x, right? So that provides a linear fall off. We can see this picture of this, right? So this green line here is that exponential function. And what the linear fall off thing does is in the bottom portion of this, you'll notice the green function doesn't actually hit 0. And obviously when we slide the slider all the way to the left, generally the user would expect the volume to be muted, not very quiet. So we fall back on this orange line around where this intersection between the green and orange lines are. And above that, we use the nice smooth exponential function. So let's go ahead and demo this exponential function instead of the linear one and see what the difference is. So did you notice the difference in the top range, right? From 0.5 to 1, the volume changes quite drastically. It's about half as loud at 0.5 as it is at 1, which is what the user would probably expect when they're dragging the volume slider. So again, I'll do the same test as I did with the first one to show that. Great, so now what about the bottom end of the range? Before it was extremely coarse. If we move the slider just a little bit from the left to about 0.1, the audio was already quite audible and it didn't feel like we had much control. So let's check out the left side of the slider now. So you notice it feels quite a bit smoother than it did before. I think this is a really simple way to make great improvement to your volume slider in your game if to implement one yourself. If you are, for some reason, worried about this exp function being a bit expensive, which you probably shouldn't be because this is a user-driven thing, right? Like, it only gets calculated when the user sets the volume by sliding the slider. You can obviously cache the intermediate value. But if you are worried about that for some reason, there is a decent approximation, which is just x to the 4th power, which is this orange line here on the chart. And you'll notice we also have a linear fall off there, which I'm actually displaying properly, so you can see it goes from a curve to a linear fall off, so that the bottom range is a little bit nicer feeling. You know, if we remove this, basically just say 0x, you'll see that it approaches 0 quite quickly, right? So we use 0, 1, and we get a little bit nicer on the lower end of the range. This curve isn't quite as good as the exponential curve, in my opinion. I did play with it. I won't demonstrate that. You can test it for yourself if you're interested. But that is an option. You just want to do a few multiplies instead of the exponential function. But definitely, this is my preferred approach. Again, that's just check if it's less than the intersection, which in the case of this particular function is 0.296. If it is less, do the linear falloff function, which is just 0.1x, right, where x is your volume. Otherwise, do the exponential function, which is exp of 5x minus 5. This is a standard C and C++ math library function. Yeah, go ahead and give that a try in your own applications, and let me know how it goes. Good luck.